Radians is the title. Radians. Let's define what a radian is here. 1 radian. So let's define it, and then you're going to draw that picture on your notes here. Well, let's define what a radian is first. An angle that intercepts an arc that is exactly the size of the radius of the circle. I'm going to copy that definition down. Another way of picturing a radian is look at this one. This is 1 radian in here. This arc is exactly the same size as the radius. How much would 2 radians be? Look at there's 2 radians. Well, it's that many degrees. So, in other words, look at 2 of these fit in there, huh? You can kind of picture it. 2 of these would fit right in here. Okay, 2 of them. There's 1 radian, 2 radians. Look at 3 radians. You can imagine 3 of them fitting in here. See, that's 1 radian, that little section. Here's 2 radians. 4 radians. Here, 1, 2, 3, 4 radians. 5 radians. And then 6 radians is almost a full circle, 6 radians. It's always 6.2 something radians is 1 complete circle. How many degrees is 1 complete circle? 360. So a complete circle would be 360 degrees if we're going to measure angles by degrees. But if we're going to measure angles by radians, it's always going to be 6 point something, like a little change. You know, we'll get into that in a little while. Okay? But right now, I just want to get into what a radian is. It's just a way of measuring an angle in a different way than degrees. Okay? Now, let's do this. I'm going to give a handout tomorrow on this right here, this little picture. So you don't have to copy this down right now. It'd be a waste of time, but I'm going to give a handout. So notice some of the common angles that we deal with. A 30-degree angle is actually pi over 6 radians. I'm going to show you how we get the radians. How about a 60-degree angle? You want to measure in radians, it will be pi over 3 radians. And I'm going to show you right now how to get these pi values. But the pi values are actually the radians. They're always expressed in terms of pi. Pi is 3.14. And that's the distance, that's actually the ratio of the circumference of the circle with the diameter. It's some mysterious number that has been obtained way back in ancient mathematics. But so pi is just it's a Greek letter, and it means 3.14. But it's actually an infinitesimal. We just round it to the nearest hundred. And you should have seen that before, prior to this, when we did the area of circles in Math 2 and such. So let's talk about radians. Let's talk about converting angles to, or degrees to radians. So on your notes, go and write how to convert degrees to radians? Put a little cloud around it. Multiply by pi over 180. So if you want to convert degrees to radians, you multiply by pi over 180. If you want to, how to convert radians to degrees? So we want to convert radians to degrees. We do the opposite, the reciprocal. Multiply by 180 over pi. I'll show you a few examples when we're done for the day. Example 1. Convert 360 degrees to radians. Convert 360 degrees to radians. How many radians would 360 degrees be? All right. So what did I just tell you? How do you convert degrees to radians in the two clouds that we just broke? Pi over 180. So we're going to take 360, do it with me, times pi over 180. That's a fraction. How do you make 360 into a fraction? How can you make 360 into a fraction? Put a 1 underneath it, huh? So numerator times numerator. So on the numerator, I'll have 360 pi. I'm not going to replace pi with 3.14 right now. I'm going to leave it as pi. It's the standard way of writing radians and your answer in terms of pi. Because once I replace pi with 3.14, I'll have to approximate because it's infinitesimal. Right now, I want to leave it as an exact answer. Denominator is 1 times 180 is 180. Can I simplify that fraction? What goes into each, Miss Perez? Right. 180 goes into 180 once, and into 360 twice. So it's really 2 pi. 2 pi radians. So 360 degrees is actually 2 pi radians. Now that's the exact amount of radians. This is the exact answer. The exact amount, 2 pi. But what if I wanted to approximate? Approximately how many radians is that? 2 pi. Well, if I wanted to approximate, we'll come back over here. Approximately how many radians is that? Well, let's see. I'll just take 2 times 3.14. So I'm going to get 2 times 3.14 on the calculator. 6.3. Approximately, huh? Because 3.14 is just an approximation of pi. If you actually hit pi on a calculator, it's actually infinitesimal. 3.14 is only approximated to the nearest hundred. So 6.3 radians is 360 degrees. .3 radians is 160 or 360 degrees. Let me go back to that picture. It actually makes sense. Watch. I'll work here. Go ahead. Let me go back to this picture of the radians. 1 radian, 2 radians, 3 radians, 4 radians, 5 radians, and now look at 6 radians here. 6 radians is 343.8 degrees. A little bit more will give you 360, so it's really 6.3 radians. You can actually see it with your eyeballs here. It's 6 and then a little bit more, about 0.3 of a radian will be a full circle, 360 degrees. So you can actually see it with this picture. 1 radian, 2, 3, 4, 5, and 6, and so on. So a full revolution around is going to be 6.3 radians, a little bit more than 6 radians. Try example 2. Convert 30 degrees to radians. Convert 30 degrees to radians. And here on this example, let's leave it as an exact answer, not approximate. So we'll leave our answer in terms of pi. I don't want to approximate, so we'll leave it be pi in our final answer. So 30 degrees times pi over 180. Cool. That's easy. Numerator times numerator, be 30 pi over 180. So we'll have a fraction now, right? That will reduce. I think 30 fits into both, if I'm not mistaken. Yeah. 30 fits into 30 once, and into 180 6 times. So it's 1 pi over 6. Or the better, more professional way to put 1 pi, just leave it as pi, because there's always a 1 coefficient in front of a variable. So it's just pi over 6 radians. That's the radians now. Pi over 6 radians. That's the exact answer. Remember, we leave it as pi. But if you wanted to approximate, you just take 3.14 divided by 6 and that's how you know the radians at A1. And that makes sense. Look at this circle. Now I'm going to give this out to you like I said yesterday. Look at 30-degree angle. Look at in radians. Pi over 6 radians. 30 degrees. It's just 2 different ways of measuring an angle. That's the main lesson today. Nothing crazy. Just another way of measuring an angle in radians. Okay? 60 degrees is pi over 3 radians. 90 degrees is pi over 2 radians. And so on. Look at pi radians. Look at pi is exactly 180 degrees. It's actually pi exactly. Okay? Last example. We're done for the day. Example 3. Going to convert 3 pi over 2 radians to degrees. So the first 2 examples of degrees for radians. Now I'm throwing radians. Now asking you to convert to degrees. What do I do at this point? What do I multiply by? 180 over pi. There we go. So I got the radians, 3 pi over 2 radians, 180 over pi, Let's convert this angle to degrees. How many degrees is this? Well, we're going to find out right now. Remember when you multiply by fractions, you can cross-cancel before you multiply anything. We can cross-cancel. Look at the pi's cancel out. How about the 2 and the 180? There's a common factor here. I can cancel out the 2. 180 divided by 2 is 90. Cool. Now it makes life more simple, huh? So numerator times numerator, that's going to be 3 times 90. I think it's 270 over 1. Lo and behold, it's 270 degrees. So you know how to convert radians to degrees, degrees to radians. Let me go back to that unit circle. Look at 2 pi over 3. Right here. 270 degrees. Here's 180. 270 is right there. There's 270. Look at the radians here. 3 pi over 2. That's what we started off with, and you convert it to 270 degrees. Okay, we've got to know how to go back and forth. Some of you still owe me quiz 6 from last week. I'll be actually going to pass it back. Make sure you get that in because tomorrow we're not going to have a quiz.